using something. So let's understand open system interconnect model using different scenes. Now we know basically each and every layer, right? We have a physical layer, data link layer, network, transport, session, presentation, application. Let's have some scenes to understand how this actually works step by step. So the story is a data packet journey from PC1 to PC2. So I have a PC1, I have a PC2. How a data is starting from 7th layer, it is going to 6, 5, 4, 3, 2, 1. Then it's coming to different application. From one application to other application, how data is getting transferred with help of OSI model, we'll understand that. Starting with the scene 1, application layer, nothing but layer 7, the request scene. Once upon a time, a user on PC1 wanted to send email to their friend on PC2. The user opened their email application. Basically, it will be what? Gmail or Outlook. He'll be opening, right? And he will type the message. He'll click the send button. Now, once he hit the send button, your application layer triggers. At the application layer, the email application took the user's message and got ready to be sent over the network. Now, this layer is defined the data format and told the network how to handle this email. So the application layer will start first, followed by the next layer, which is presentation layer. Now we have data, right? Now data from application layer will be going to the presentation layer. Nothing but data translation. Now this layer acts as translator. See, as a human being, when you type data, you're typing in English words. Yeah. Does my computer understand English? No. There must be a way to convert your English language words into machine readable binary formats, which is zeros and ones, so that your computer can understand it. If you have some kind of security implemented, like encryption implemented, in that case, presentation layer will also take care of encrypting the data so that it is going secure. See, I can send two types of email. Either it can be a secure email, unsecure email. If I want to secure my email, apart from just converting my data into zeros and ones, to also put some additional security. That also be done by presentation layer. Data translation. Scene 3. Now data came to from application to presentation layer. It get converted into zeros and ones. Now then scene 3 comes, where your session layer comes into picture. Think about layer 5. The connection setup. To send this email, PC1 need to open a new connection, right? The road bridge has to be built. So before even you send the short data, the PC1 will create a bridge connection or connection session from PC1 to PC2. Now the session layer comes into play here, setting up connection between PC1 to PC2. Imagine a bridge. Over the bridge, imagine a water is flowing here. I want there's some data parcel from here to here. Parcel is ready, encrypted, you put in the box, but you have to have a bridge, right? Correct. Now think of this like starting a phone call between two computers, ensuring they can talk back and forth. Before you start talking, the ring should go, connection establishing, that is session layer. Then you got layer 4, where scene 4 happens. Transport layer, reliable delivery. Now, at the transport layer, the email message was broken into small pieces, and they are termed as segments. Now, this layer makes sure data is sent reliably. Reliably means, imagine a very big parcel came. Now you have to break them into small chunks so that you can go very fast and also reliable. It should go there. Correct. If you send it in bulk, it will become slow. So you break it in small pieces. Now PC1 uses TCP, transmission control protocol, to make sure segment is arrived at PC2 correctly. Okay. Now it does two functionalities. Now it takes care about how the data is being sent using TCP. It also makes sure data is received here. Once received, he should send me an acknowledgement saying I received it. TCP will take care of that also. TCP also ensures that if any piece of data is lost, it makes sure the sender again resends that piece of data. Imagine that from one laptop to other laptop, you're sending a 1 GB of software file. Even if 2 MB of file is missing, will the software function normally? It will say some file is missing. So how do I make sure even the 2 MB is not missed using transport layer?
So if something is missed, create another copy, we store it.
My laptop will have another copy. So sometimes when you copy your file, right, from here to there, if you delete the source file, even though this copy is going on, it'll stop functioning. We should have a copy always. So that once if something is missing, I can resend again. Reliability. Now next, scene 5 happens where you have network layer, nothing but layer 3, where addressing and routing will happen. See, now the bridge is formed through that river. Now this bridge is formed where I'm going to send actual user setting is where? There should be an actual human or user, right? Who is going to use that product. The bridge is formed, data came, where it should go, I don't know. For that, we need layer 3. Now data segments moved into network layer where each segment was given an IP address. Now that is where your IP address comes into picture. See, your application layer, presentation layer, session layer, no IP address, no MAC address. It's coming, just data is getting into different formats. And it is deciding I should use TCP. It is establishing a session. Now it will find out, it will put the IP address. Okay, it's like you're sending a mobile phone, you have made a box, everything pack is ready. Now is where you write from address and to address. That stage came now. Now this is like addressing an envelope with senders or PC1's IP address and PC2's IP address. Now network layer makes sure the data knew which path I should take to reach PC2. It has to navigate through different routers and networks in between. Then the scene 6 comes into picture where you have data link layer. See, I should always tell you that there's a difference between IP address and MAC address in this term. Why do we need two addresses? One is IP address, MAC is also an address. Why do I want two address?
It's like imagine this. That down there are 5 people. So if you want to send it to, let's say, you have to know which room to send it.
Correct.
That is why name happens.
Exactly.
You have to know town. That is why you need.
Exactly. So using an IP address, a packet can come all the way to that street or that network. In that street, which device I want to send traffic, I can have 10-15 devices. That will be decided by MAC address. So using an IP address, a packet can come all the way to your network. So in that network, I may have thousands of PCs. To which PC I have to send? I use MAC address. So the segment reached data link layer where they are organized into smaller units called frames. That's called PDU. Now each frame was given a MAC address, a unique identifier for hardware like network interface cards or PC's network interface card. At this stage, data is moved between local devices like switches or routers on the same network between the PC2 or PC1 like that. It goes.
Postman.
It's like a postman. Now the layer scene 7 comes physical like about. We have physical layer where the physical transmission happens. Finally, the frame reached physical layer, the foundation of OSI layer or OSI model. This layer converts the entire data into electrical signals or light pulses or radio waves. See, a lot of people imagine that these bits and bytes is getting converted here only. No, zeros and ones is not here. Where is zeros and ones? Presentation layer. In presentation layer itself, my data is converted into zeros and ones. It's coming all the way to physical layer. Now my data is completely packed. Now I have to convert them into like this electrical signals. If I'm using Ethernet cable, electrical signals, light fiber cable means light signals, Wi-Fi means radio waves. You convert them depending on the connection type. And it will be sent over the physical medium, whether it is a Ethernet cable, fiber optic cable or Wi-Fi. Now the data physically travels across the network to reach PC2. Now after reaching PC2, again the step will be reversed. The reverse journey of PC2 happens now. When the data arrived at PC2, the process happened in reverse. Data moved up from physical layer all the way to application layer. It will unlock each and every information which you packed, like IP address packing, MAC address. It will open everything. It will reach all the way to another application, and you will be able to see the email. I have encrypted done here. The decryption will happen. Like that happens.
So Gmail will have both the transportation method and the decryption.
Because you are sending, he should receive, again should follow the ulta steps, right? Reverse steps. So the conclusion is that mission is completed now. Through the journey across all 7 layers of OSI model, the email successfully traveled from PC1 to PC2, arriving safely in the inbox without losing a single word you have sent. So this is what happens from layer of OSI models. Okay.